And welcome to the lesson about graphing radical equations. Just like we graph any other equation, we are going to start by making a table and or t-chart, whichever one you want to call it. So I got all my x values. I substitute that value in for x, and I find out the corresponding y value. So I found the first four y values and their x values. First thing, when you're doing square root equations, first thing you want to check is what is going to make this radical negative. So what inside the radical is going to be, how will the inside of the radical be negative? Because we know it can't be. You cannot take the square root of a negative number. So what you need to do is take what's inside the radical, set it equal to 0. Actually, you want to set it greater than or equal to 0. We know that whatever's inside of the radical has to be greater than or equal to 0. From there, I'm going to add x to both sides. It's just solving inequality. And I have 3 is greater than or equal to x, so x has to be less than or equal to 3. Now I'm going to plot my points, which I did, and then from there you're going to draw a curve. Notice it does not go any lower than here because y cannot be negative. The function cannot be negative. There are no negative values for the function. If we look at the parent function, it's y equals the square root of x. So here is y equals the square root of x. X cannot be anything less than 0, and y can never be negative. Here is the common shape. If you kind of tilt your head to the right, you'll see that it's half of a parabola. Tilt your head to the right so that you're looking at it all the way 90 degrees. You see that it's half a parabola. So if you think about the inverse of this function is y equals x squared, which would look like this. Okay, that's just a little more information for you, but whenever you're solving square root equations, know that this is the common shape of the parent function. And so that shape will be altered depending on what's done to the parent function. So the parent function is y equals square root of x, and we're looking at here the graph of y equals the square root of 3 minus x. If we rewrite that, we have y equals the square root of negative x plus 3. So if here is our parent function, it is changed by this positive 3. Now you would think it goes to the right, but actually it goes 3 to the left. So 1, 2, 3. So now I have something that looks like this. Now, this x is multiplied by a negative, therefore it is reflected along the y-axis, and if I do that, if I take that perfect mirror image of this graph right here, if I mirror that perfectly over the y-axis, I do indeed see how this is negative 3, it would be at positive 3 now. They would both intersect at the same place. and I would get the function that you see there outlined in blue that I just tried to outline but terribly failed at. And you can take what you just learned and also apply that to cube functions. Cube functions, for example, if I had y equals square root of 3 minus x, and instead of square root it was third root. Well, it would be the same kind of shift. It would be to the left first and then reflected, so therefore it would look like, it would look like this. Okay, so it would have the same type of shifts. The only thing is there is also a negative and opposite side to the cube function now, because we can take the cube root of negative numbers. That's all I have for this lesson. Hope you enjoyed yourself. Hope you learned some stuff. If you're still confused, go back, watch the lesson again, take some good notes. Reach out to me if you have any questions. Good luck on your homework assignment. If you need help on that, go to the Math Cafe, open from 9 to 3 every day, and make sure you come to live class where we can talk about this a little more.